The 3D Print Lab has enabled the college to act as an applied research hub, a research and development hub for industry, as well as allow the college to expand its curriculum offerings and the type of training that students get here at Medicine Hat College. Within the lab, we have a fused deposition model 3D printer that is state-of-the-art. There are many different applications with respect to 3D printing. And I think we've just scratched the surface as to what the lab is capable of doing. It's a much cheaper and faster and more time-effective way of being able to get a product to market. The process begins with a 3D virtual model that the client provides. In this case, we'll be creating a gear for a wheel. That model is converted to what is known as a stereolithography or STL file. That file is reviewed by the lab technician to see if it's actually printable, because there may be gaps or holes within that file, and we need to be able to eliminate those so it will print properly. In other words, the file has to be what is known as watertight. So that's critical. Once any problem areas are addressed, the fabrication technician can then essentially slice the design into hundreds of layers into which the printer will build layer by layer. Once that is done, tool paths are then created, because the tool paths actually are going to tell the printer head, or the tip at the printer, exactly where to print. Imagine a hot glue gun that's computer controlled and does exactly what you want to do. That's essentially what's going on here. Then we decide upon the model and the support material. Now, the model material is the actual material that is printed, but the other material that is used is called support material, because you cannot build in air. It is what prevents unintended parts of modeled material being fused with each other, fused together. If you have a piece of material that overhangs or extends as part of your model, you need something to support it with, so that's where the support material comes in. Once the model is analyzed with both the product and the support material, the technician then does one final pass to ensure that there will be no problems with its building. The STL file is transferred to the software known as Insight. With Insight, you're able to place that model on the build sheet. And so what you can do is make your builds very efficient. And the build sheet is the foundation upon which the model is actually printed. The software will actually allow for the efficient use of build sheets and putting as many objects as possible for one build. Once the model is in the Insight software and put on the build sheet, what the software will tell is how much model and support material will be required. And this is important because that will also determine the time that is required for the print job. This particular gear took about 4 hours to build. Once it is completed, the technician will then remove it from the printer, and it's put into what is known as a clean station. And that clean station has a caustic solution with a basic pH of about 10 to 12. And that is put in that solution for about 5 hours. What that does is it removes the support material, so you're just left with the product material. Once that is finished, then what you do is you take out the model, you put it into just regular water, and you get rid of the caustic solution that's on the surface areas of the model. You then drip dry the model, and once it's dry, the model is then given to the client. Medicine Hat College is very excited about these advanced manufacturing technologies and the capabilities that students will have when they engage with the technologies to go out and work for companies and start their own companies that will apply these innovative technologies in their business models.